Hello everyone, welcome to CassiniCraft, and today is a full English video. Well, we're gonna explore a little bit more about the solar system. This representation is very beautiful, very true, I suppose. And look at this three-eye atlas coming to very distance, from the solar system. If you see trajectory, it's really fast and coming to very distance. What is this? This is a very deep question. But now we're gonna look the Earth. All right, here we have some tools here. We can do high quality. All right. And tools. What we're gonna do now is to compare distance. Distance from Earth to, let's search the first. The target here is to figure out a Venus target and to show the second mission, Cassini 2.0, that I'm working at. It must be. We're gonna refine this a lot of times, but Venus, let's see Venus. This is the distance. I guess it's a good choice. We keep this in mind. 255.4 million kilometers. This will be the distance. The spacecraft must fall into Sun and Venus. And let's check it out, Venus. Let's go to Venus. Oh, right. Here it's Venus. So this is a illustrative representation of it. And here we're gonna do compare the size. There was a tool here. Compare the size. This is the Mercury, Earth. So it's almost like the same size. So we can use some physics constants as well as in the Earth, using here in Venus to make our calculus. Let's go back. And now we're gonna do in the telescope mode. However, before it, we just need this. This is the true target, Saturn. So imagine the spacecraft here falling to this atmosphere. What is the distance? Let's calculate the distance to Saturn. Yeah, it's too far away from Venus. 1.36 billion of kilometers. So the calcul must be very precisely, because at this point we're going to use a telescope to illustrate what the calculus that the Cassini must be do. Telescope here, and at this point here, go. And then the moment, the spacecraft will very close to the Venus atmosphere, so it must be take to the sky the position of Saturn, but this is the main target. The calculus must be determined what is the position of Saturn in the future, 1 billion kilometers after. So it must be calculate the velocity of the spacecraft and what must be the position of Saturn after the 1 billion kilometers flying through the space. It's not here itself. It's a little close to the left. How much to the left? And this calculus must be do it with a very high precision, And I am studying this by this C code, There is assembly instruction. What is this command do? Well, go to the kernel of the processor and take me the number that represent how many times the silicon vibrate when the electricity passes through it. So how much time? The time here is different because we have to think about nanosecond. 1 second. Take 1 second and divide it into 1 billion of equal parts. You know, each one is when the silicon shake in the kernel. So we can do this. You start this information, and after the operations that must be very precisely, you take again and compare how many times the silicon vibrate. It's not about how many seconds it proceeds, it's about how many times the hardware shaken. So after this Venus, we're gonna go to Saturn right now itself, because when they arrive in Saturn, yeah, let's go. Well, here we get a lot of things.